Hey everyone, welcome back to the channel. On today's video, we are going to discuss a service that when I started learning about Azure, I found it really complex, but at the same time very powerful. It has a lot of moving parts that if we don't understand very well, it's going to be very hard to troubleshoot any issues. It is the application gateway, and I think that if you ask anybody, they think they know it until they really have to go and deep dive into an issue. Today we will cover the core functionalities, listeners on both private and public frontends. We'll cover path-based routing, TLS offloading. We will cover URL redirects, and help props. So let's get into it. Before I start explaining each component of the application gateway, I want to give some definitions and compare the application gateway with other Azure resources that may seem similar, but they are actually not at all, like the Azure Load Balancer and Front Door. For that, we have this graph in which we have layer 4 and layer 7 based on the OSI model. Layer 4 works for TCP and UDP packets, and layer 7 is HTTP and HTTPS protocols. Why is that important? Because the application gateway is a load balancer that works at the layer 7, which means that it can understand HTTP or HTTPS. That means that it reads headers, cookies, path, host names, and based on those parameters, it can route. It can take decisions based on those parameters to decide the routing. It is completely different to what we have for Azure Load Balancer, which is a layer 4 load balancer. It understands TCP and UDP packets. It doesn't know anything about HTTP or HTTPS. And it's also different from Azure Front Door in, I think, one word, which is scope. An application gateway is regional, which means that it lives inside your VNet, inside your virtual network. And the idea is that the application gateway is close to your backends. While Azure Front Door is a global service, it has different edge points of presence around the world to improve performance and redundancy. If your application is in a single region and needs L7 routing, or TLS offloading or WAF, and you need it at the edge of your VNet, then that's the application gateway. However, if you need a multi-region or CDN style acceleration, is where Azure Front Door comes in. And often this is layered on top of the application gateway. Everything starts with a listener. A listener is like a logical unit that catches an incoming request, and it does so based on 4 attributes: protocol, port, hostname, and frontend IP. You need at least one listener if you want to use an application gateway. And there is 2 types of listeners. A basic listener, which basically you have your application gateway handles only one side. That is not the case for real scenarios. And the other one is multi-site listening, which is what is more common in real production environments. And why it's more common? Because this lets you host more than 100 websites behind one application gateway. So let's say that we have different incoming requests, and they are pointing to the same application gateway. Each of these domains get its own listener and its own backend pool. So based on that, the application gateway is able to route the incoming requests to different backends without having to have multiple application gateways. And you can even define something that is called a wildcard host name, which is basically everything that matches this, go and redirect it to this backend pool. This is one feature that I would like to mention, and because I think this is something skipped in most of the tutorials, and is the option to have public and private listeners. So as I mentioned in this diagram, a listener matches the incoming requests based on 4 properties: protocol, port, hostname, and frontend IP. At the beginning of the application gateway, you couldn't have both a public and a private listener using the same 4 attributes. So if you wanted to serve internet traffic and internal traffic, you at least have to change one of these properties or attributes. That was updated, and now you can have a public and a private listeners using the same 4 attributes. What that means is that one application gateway can serve internet traffic on its public IP and the internal only on its private IP, right? Because an application gateway can have both public and private IP. And you could have completely different listeners, rules, and backends behind each. So what you need to do is point each listener at the frontend IP configuration that you want. All this that I just mentioned is reflected in Terraform in this way. We have to define 2 frontend IP configuration, one for the public and another for the private, along with the frontend ports that we want to define. In this case, it's port 80 and port 443, which is actually the port that HTTP applications use. And then one thing that I would like to emphasize, port 80 is not secure, and we use it, we define it only with the purpose of redirect to HTTPS. That's the reason why here the HTTP listener exists for port 80. It's only to redirect to HTTPS. And then we have both the public and the private one. As you can see, it has all the attributes the same except for the front-end IP configuration. And one last comment is that the order in which you define those listeners matters. So if you, for example, define a basic listener before a multi-site listener, then the basic listener will get all the traffic, and then it will never come to the multi-site listener. So just be careful, because I've seen that that is a real source of, for example, why is my traffic going to the wrong backends? And it's that type of bug that if you haven't seen it before, it's going to be very hard for you to troubleshoot. Once a listener catches the request, a request routing rule, it's the one that decides where it goes. This rule binds three things together: the listener, the backend pool, and a backend HTTP setting. We will see them in a moment. And there are two rule types. The basic one, which basically forwards everything on that listener to a single backend pool. It's very simple. And the most advanced feature is the path-based routing rule, which reads the URL path and sends that request to a different backend pool based on what it matches. So let's say that we have a request on this /API. So those requests will be redirected to your API pool. Similarly, if you have your images, it's going to a static content pool, and so on. And if there is nothing that matches, it is a good practice to define a default one. For the request routing rule, is also important the order in which they are listed. So if a request could match two patterns, the first one is the map that wins. That's it. And the second one would never be matched. So order your most specific path first. Okay, how they are defined in Terraform. For Terraform, we have to define a URL path map, and we define what is going to be the default backend address pool, the default backend HTTP settings in case there is nothing that matches. And we define then the path rules for each path. We have to again define the address pool, the HTTP settings. And once you have this map defined, you need to define the routing rules. The one that we are interested in is the request from the HTTPS to path-based routing. And then we define that we have a path-based routing type, and the map name is going to be UPM main, which is the one that we define here. And that's all. We have to define a priority for the routings. Remember that it's very important. You have to keep the most specific ones at the beginning if you want to avoid any unexpected behaviors. The backend pool is just the targets where those requests are sent to, and it can be almost anything. It can be a VM, a virtual machine scale set, a raw API, FQDNs, an app service. They can live in your VNet or in a peer VNet. And then we have the concept of an HTTP setting. So the HTTP setting will define how the gateway will communicate with the backend pool. So we already saw how the listener defines the incoming request. For the backend request from the application gateway to the backend pool is where the HTTP setting comes in. So we define the port, the protocol, the request timeout, and more advanced features. Let's talk about TLS termination, because that is the default pattern that the application gateway matches. For that, we need to divide that into two: the SSL termination that comes from the client, and then from the application gateway to the backend. The client's TLS handshake, when it was initiated, ends at the application gateway, and the traffic to the backend flows in plain text if you don't have anything else in place. The benefit of having this one is that it offloads the encryption and decryption from your web servers. So the gateway does the expensive part. However, in most of the environments, the application gateway can send plain text to the backend because compliance rules or zero trust policies and so on. For those, the application gateway supports end-to-end TLS. How it looks like: it terminates the client connection, and then it opens a brand new connection to the backends using the backend's certificate. So the client's connection ends in the app gateway, and then the app gateway opens a brand new one to the backend using the backend's certificate. The way the application gateway uses the certificate is through the Azure Key Vault integration for both the listeners and also the communication between the application gateway and the backend pools. A URL and header rewrite are, I think, one of the most underused features of the whole service. The rewrite basically lets you add, remove, or modify any HTTP request or response header. So let's say this incoming request with these headers. Once it comes to the application gateway and there is a rewrite rule set, as I just mentioned, you could add a response header, a strict response header, and you could even rewrite the URL path. A possible result of this could be to the backend, it changed the path, it removed this header called server, and it added a new header called strict transport security. The last part that I want to cover is redirection on the application gateway, because I think it's more flexible than the classic one that just being redirected from port 80 to port 443. So the classic one is important, right? We have the HTTP listener on port 80, and then we do a redirect to an HTTPS listener. The reason for that one is because we don't want any unencrypted traffic. We always want that our traffic is secure. This basic mechanism can be generalized. You can redirect from and to any port. You can do path-based redirect. So let's say in this case that you want to redirect only when there is an incoming request in the /card. You want to redirect to a new path, or you could redirect to an external site. When it comes to the root domain, you want to redirect it to an external site. That is also possible. So in summary, you could redirect to another listener, to a new path, or to an external site. And each redirect can be permanent or can be also temporary. The difference between this is the status codes that you get when it is redirected. When it is permanent, you get 301, and when it's temporary, you get 302. And additionally, you could also, while doing the redirection, you could choose whether to append the original path and query strings to the target. In Terraform, the redirection looks like this. You have to define a redirect configuration. In this case, I'm giving the name. I'm saying it's permanent, so I'm gonna get a 301 when the browser does the redirection. And then what is gonna be the target? The target in this case is a listener, so I'm gonna put the listener name of the HTTPS. And then if I want to include the path and the query strings. So this listener path is not always required. If you want to redirect to an external site, you could put this into null and pass the URL to the external site. And then this redirect configuration needs to be attached to a routing rule, which is in this case, it is here, the rule type, and it says what is going to be the redirect configuration name. And that's everything. So here's the mental model the next time that you think about the application gateway. So think about it like a clean pipeline where the listener catches the request and there is a rule that decides where it goes. It can be a path-based or it can be a basic rule. And then we have backend pool servers that can be a VM or an app service. And then also there is a health proof that makes sure that that backend still receives traffic because it is healthy, or just the application gateway blocks the traffic because it is unhealthy. We have TLS termination at the application gateway, and then the application gateway initiates a new connection to the backend, so that the backend traffic is also encrypted, and we can do rewrites of headers, path, and also redirects. If you find this useful, subscribe for more content like this, and let me know in the comments what you think about the application gateway, what you like the most and what you don't like. Bye bye.